Good morning, class. As you know, we're studying erosion in our science class. And so I brought you to Northwestern Park. Many of you were here last year, got to come to this area when it was Northwestern Lake before Condit Dam was taken out. So I wanted to bring it back so you can see the aftermath of the flood. And as I pan over, I want you to look at the undercutting here, leaving the roots of the trees exposed. Now this happened from corrosion and corrasion, which is the process of the river's load crashing and rubbing into the river's banks and beds, causing pieces to break off, as well as the process of the water dissolving the river's load, as well as its banks and its beds. And you can see all this along the banks. As we look forward here, you can see the deposit of rocks that was left that came from upstream when the dam blew. And the force of the water just brought those down and deposited them on each side of the bank. As you remember, erosion is the process of wearing something away. And the river erodes in four main ways: attrition, corrosion, corrasion, and hydraulic action. We're going to look at a lot of corrosion and corrasion, as well as hydraulic action. And we'll see some of that as I take you upstream about 2.5 miles later. But I want you to take notice of the sediment, how it changed the water. And that's from all the buildup of sediment when the dam blew, it dropped it off here. Now, I want you to take notice of the lighter sediment that has come up to the surface. Just like in our stream table models, the clay has come up and was deposited. And I've marked it with my finger and the words on the screen. I just think it's awesome that you guys are able to see this in our hometown in real life as we're doing the models in class. Now, as I climb up on these rocks, I want you to look across the banks. I have a good shot here of the undercutting and exposed roots, as well as take notice of the rocks that I'm standing on. Now, these were put here to help stop erosion, as well as the grass that was planted. As we walked down, you saw that grass. Now, remember, the more vegetation that you have around, the roots hold the topsoil in, and that just helps from further erosion if there was another flood. As I zoom in, you can see the house up here, and that's important because if you remember, this entire area was filled with water, and that was the water level at one point. It's really hard to imagine that a year and a half ago, this whole area was just a lake, and there wasn't any moving water. Now, I've brought you down about 500 feet downstream, and I did this because there's some really great erosion I want you to take a look at. And as we pan over, you're seeing the floodplain now of what's the White Salmon River, as well as a slip-off slope or point bar. Now, the slip-off slope is formed on the side of the river with the greatest deposition, usually the inside of the meander. And if you remember from a vocabulary, a meander is just simply a bend in the river. And there's quite a few here on the White Salmon. I want you to look across, and I want you to see some of the corrosion there and how it's cut through. The sheer force of the flood just carved a whole new pathway for this river to come through. It's got a whole new direction now. It's great. As well as the siltation, which is the process of the load bouncing along the riverbed, has caused a lot of this cut-in, like what we're looking at now. And here we're looking at a sandbar. Now, that's the sediments and silt, as long as gravel that gets piled up in one area. And so that's what we were looking at there. And now we're looking at the grass that's being cut out here, and you can see it's a great erosion. It's corrosion or abrasion. And again, that's caused by the load crashing and rubbing into the river's banks and beds, causing pieces to break off, as you can see here. To me, it's amazing. If you had never been here, you'd never know this just wasn't a riverbed. And it was just a big lake. Well, here I've taken you about 2.5 miles upstream. And again, you can see the point bar or slip-off slope in that meander, as well as the corrosion and corrasion that was going on that just dug this deep canyon from the force of the water. And this erosion here is both downward, deepening this valley, and headward, or extending out to the valley's hillside. And you can see all this happening here. I wanted to show you this area here because, again, they're planting more trees, as well as this flat area that's all around, of course, was covered in water. So now there's no topsoil there. There's been a lot of dust storms as well, and that is eroding that soil away as well. So that's another issue that's happened. If you look at this horseshoe-shaped area, this is where the water came down and was crashing into the rock and falling down and plunging there, and then it was kind of turning around, causing the circle formation there, and that's a really great sign of erosion there as well. Now, in the next few shows that's coming up here, in the next segment, I'm going to show you how this whole started. So what we're going to look at is I borrowed a video from Andy Massey, and it's a time lapse of the Connet Dam and all the erosion over the hour and a half. So really look at the erosion and what's going on down the river.